Calculate the value of the angle marked alpha in the diagram given below. I welcome you all to another edition of ND Chris tutorial. There is a problem upon us here. You have been given this diagram and you are expected to find this angle marked alpha. How do we go about solving this problem? Previously, we utilized the Pythagoras theorem when looking for a given side of a right angle triangle when two other sides are known. So in today's edition, it's a distinct case. Let us analyze this diagram here. If I break this diagram, for instance, if I bring out this side of the diagram, which is marked A, D, C. The angle here, the length of this side AC is 10 cm. There is an angle given here, which is 60 degrees. Now, because this side is right angle triangle, as you can see, this is also right angle triangle. All right. How do we label this triangle now? I told us previously that the longest side, which is facing the right angle triangle, is known as the what? Hypotenuse. Now, there's a given angle here in this triangle. So because of this given angle, the side facing the given angle now is known as the opposite. So this becomes your opposite. Then the remaining side becomes the adjacent. There is one limitation here. We cannot use the Pythagoras theorem to solve this problem. Why? Because only one side is given. So if we are to find the adjacent, we need to know the hypotenuse and the opposite. Unfortunately, that has not been given to us. So what do? How do we find adjacent? How do we find the opposite when only the hypotenuse is given and there is an included angle? It's very simple. All right? Don't stress. This will lead us to what we call SOHCAHTOA. I will tell us what this stands for. It's an acronym. Now, the S here denotes sine. Sine, theta, I'm going to use theta. I will tell us why. O here means the opposite. And the H represents your hypotenuse. Similarly, C here represents cos theta. Who can tell me what A is? The adjacent. So it's just a short form of writing it. Then the H, of course, signifies your hypotenuse. And lastly, we have T representing tan theta. O becomes our opposite. And adjacent, of course, A represents our adjacent. So it is good you memorize this. The way the Pythagoras theorem is important, that is how this is important. Remember that this is used when you are looking for an included angle other than the angle 90, or when a given side is known, just like this one now, only one side is known and there is an angle included. That is when you resort to using SOHCAHTOA. Now that we have labeled this triangle this way, we have the opposite, we have the hypotenuse, and we have the adjacent. And there's an angle here included, and there is a length given. Which of these do you think is most suitable? If I want to find my opposite, I can find it. If I want to find my adjacent, I can find it. But because of what we are looking for, and in order to save time, it is better to quickly find the adjacent. Once we know the adjacent, we can find this angle here. So what do? I want to find my adjacent. I have the hypotenuse given to me and I want to find the adjacent. So which of these connects adjacent and hypotenuse together? I can see adjacent here and hypotenuse here. All right. So I'm going to use cos theta. The theta, please, represents the included angle. That is the angle sustained by the triangle. All right. So I'm going to use what? Cos theta. It says cos theta equals to adjacent all over hypotenuse. What is our theta? The angle given. I already told us that. So we have cos 60 degrees as given equal to, what's the adjacent is unknown, or you can call it CD. Alright, so we call this side CD all over hypotenuse, which is 10. As you can see, from here to here is AC, which is 10. So what do? We cross multiply, right? Therefore, CD equals to cos 60 degrees times 10, which is cos 60 degrees, that's opposite of sine 60, sine 30. That should be 0.5 times 10, and that will give us 5 cm. It then means that from here to here is what? 5 cm. If we go back to the original diagram. Now that we know that the adjacent is 5 cm and the opposite here is 12 cm, we can actually find this angle here. Even if you want, you can find this side now. You can use the Pythagoras theorem to find the hypotenuse, since you know your adjacent and your opposite. Why is this place the opposite now? There's an angle here it is facing, as you can see. So the angle alpha is facing this side, therefore this is the opposite. So you can bring it out if you want. This is your 12 cm as given. This is the angle you are looking for, alpha. This side is 5 cm from our calculation, and then this is B, this is D, and this is our C. So we have, what do we call this? This is the hypotenuse, please take note. And this becomes the opposite, it's facing the given angle. The other side that is left becomes the adjacent. But we are looking for this angle. We don't know the hypotenuse, so unfortunately, we cannot use any relationship that involves the hypotenuse. So this is ruled out. We can't use sine theta. We cannot use cos theta. Why? Because there is no hypotenuse, it's not known. Alright? We know our opposite and we know our adjacent. So we have to use the relationship that involves these two. And that goes to this. So we're going to use tan theta. So we say tan theta equals to opposite all over adjacent. Remember that we don't know the theta, which is the angle. Or, sorry, we can change it to the angle given. So we're using alpha instead. Tan alpha. What's our opposite? Yeah, from the given diagram, the opposite is what is facing the angle. We are looking for 12. That's the opposite. And then the adjacent is 5. Alright? Watch me. Tan alpha equals to 12 all over 5. This will give us 2.4. How do we find our alpha? Take your calculator. Let me show you what you have to do. But before you do that, we have that alpha equals to tan inverse 2.4. So what's our alpha? How do you get tan inverse? This is my calculator now. Press shift, then press tan. You can see that is the tan inverse. What's the value you're looking for? 2.4. And this will give us what? 67.38. We can round it up to 67.4 degrees. So that's the value of this angle here. Alright? So you see how it is done. I brought this up to show us the limitation attached to the Pythagoras theorem. It is only usable when you have two sides given and then you're looking for the third side. Once you have a side given, I'm talking about right angle triangle, and there's an included angle, you can go ahead to find the second side and therefore apply the Pythagoras theorem. Alright, so this SOHCAHTOA should be handy, it should be memorized easily, the same way you must learn to memorize the Pythagoras theorem. Thank you so much. I will see you in my next class. Bye.